If you've ever looked at game hacking or reverse engineering code, you've probably seen random looking numbers like these. And at first, these just look like completely random hexadecimal numbers. But they're not random. They're called offsets. And once you understand what an offset actually is, a lot of game memory code starts making way more sense. Imagine a game has a player object that looks something like this. So you have your struct player and then all the values inside the player. For example, the health, the ammo, and the positions. When this object exists in memory, those values need to be stored somewhere, right? So let's imagine the player starts at a memory address 0x5000. Now let's lay out the values after it. So let's say the health is 0x5000, and then the ammo would be 0x5004, and then the X position would be 0x5008, and so on. Notice something important. Every value is a certain distance away from the beginning of the player's object. That distance is the offset. The word offset literally just means a distance from the starting point. So if our player begins at 0x5000 and health is stored exactly at that beginning, then the health has an offset of 0x and then 00. Ammo is 4 bytes after that start, so the ammo has an offset of 0x04. X bytes after the start, so the X offset would be 0x08, because we're adding 4 on top of 4, which is 8. You can think of it like this. Player base address plus the offset equals the address of the value. For example, 0x5000, our player base, plus 0x04, which was the ammo. So we get the value of that, which would give us the ammo. That's where our ammo was stored. That's all an offset is. It's just a distance from a known starting address. You might also be wondering why offsets usually look like this, instead of looking like normal numbers. That's hexadecimal. The 0x at the front tells us that the number is being written from in base 16. Okay. Programmers use hexadecimal a lot when working with memory because it lines up nicely with the bytes and the addresses. For example, 0x10 gives us 16, 0x20 gives us 32, and 0x100 gives us 256. So when you see health equals, for example, 0xf8, it doesn't mean the health value is f8. It means the health is located 0xf8 bytes away from the start of some object. It's like your player object, player base. That's a really important distinction. Now let's connect this back to some kind of code that you've probably seen before. Imagine we have our player's base address, let's say again, 0x5000. And we know the health offset is 0xf8. So conceptually, the health address would be the player plus the health offset. So the player address plus the health offset equals the health address. So if player equals to 0x5000 and the health offset is 0xf8, then we're moving the f8 bytes forward from the beginning of that player's object. This is called address arithmetic. So this is why you constantly see addition when working with offsets. Why are offsets useful? Offsets are useful because the entire player object can move some offset memory, while the layout inside the object can stay the same. For example, one time the player might start at 0x5000, another time it might be 0x9000, but the health might still be the same 0xf8. So instead of saying health always lives at that same exact address, we can say find the player, then move f8 bytes forward. That's way more flexible. And this connects directly to pointers. A pointer can help us find the player object. Then offsets help us find individual values inside that object, like the health, the ammo, positions, team, everything, name. Why offsets can change. Offsets are not guaranteed to stay the same forever. If a developer updates a game and changes the player structure, maybe they add another variable here. So maybe they add armor to the game or reorder some fields. The layout and memory can change. That means an old offset now might point to something wrong. So an offset like 0xf8, which could be your health, isn't some universal health offset. It only makes sense for the specific structure and version it came from. That's why you'll often see the offset list tied to a particular game's build or versions. Let's recap. An address is an actual location in memory. An offset is a distance from a starting address. And usually the basic relationship is base address plus the offset equals your target address. So if you ever see something like player plus, for example, 0xf8, don't think of f8 as a mysterious hacker number. It simply means start at the player and move f8 bytes forward. That's an offset. Thank you guys for watching this video. And in the last video, we learned why pointers are useful. Now we know how offsets let us move through the data inside an object. The next logical step is figuring out what happens when a game has more than one player. Because obviously, a multiplayer game doesn't just have one player object sitting in memory. So next we can look at how an entity list work and how games keep track of multiple players and objects at once. Subscribe if you want to follow the series, and I'll see you in the next one.